Hello AP Chem students and welcome to topic 5.8, reaction mechanism and rate law. So the learning objective for this topic is 5.8.8, identify the rate law for a reaction from a mechanism in which the first step is rate limiting. So this really does build off of topic 5.7 when we talked about reaction mechanisms. So we've already talked about the first requirement for mechanisms and how that requirement is that the stoichiometry of the mechanism overall must match the stoichiometry for the overall reaction. So the second requirement for mechanisms is what we're going to talk about today. So this requirement is that the rate law of the slow step must match the experimentally determined rate law. So this requirement introduces the idea of a rate limiting step, sometimes also called the rate determining step. So the slowest step of the reaction that limits the rate of the overall reaction mechanism. So that's your rate determining step. In many mechanisms that you'll see, the steps will be labeled as being fast or slow. And these labels can be important in how you treat that step in terms of its part and the part it plays in the overall mechanism. So the slow step, just like any chain is only as strong as its weakest link, a reaction is only as fast as its slowest step. So therefore, the rate determining step provides the rate law for the mechanism, because that step is what slows everything down. Any other step is going to move faster than that, and so it's not going to determine the rate law. The rate law is going to be determined by the slow step because that is what sets the rate. So that's what looked at. So this step is often the first step in a reaction mechanism because this is the step that is the most difficult, as the species have to interact correctly according to the collision theory. Remember talking about the collision theory. So remember that because the steps in a reaction mechanism are elementary reactions, their rate laws are determined from their molecularity, which stoichiometry, right? So in other words, because these are elementary steps, you can use the coefficients to determine the rate law. So if we look at the reaction between NO2 and CO, which I believe is the same one that we looked at in topic 5.7, we have our first step, which is slow, and our second step, which is not marked here, but we do have the first step marked as being slow. So in this case, the rate law would be equal to lowercase k, the rate constant. Remember, it's not a rate law if you don't include a rate constant. And then NO2 squared. And that's because we have 1, 2 NO2s. Sorry about the bell. Okay, and that's actually it, right, for this learning objective, this topic. So what should you be able to do? You should be able to use the slow step of a mechanism to write the rate law for the overall mechanism. Now, you can also turn this around. If you are given the rate law, you should be able to identify the slow step because the mechanism's rate law matches the slow step. So there you go. Pretty short, sweet in this one, and I will see you soon for topic 5.9.